In any acid-base reaction, the acid and base, as we said before, will be transformed into the conjugate acid and the conjugate base respectively. And the question is, how do I transform an acid into a conjugate base, or how do I transfer a base into a conjugate acid? For example, if I have HA, to convert this acid into a conjugate base, you have to remove a hydrogen from the molecular formula, and you have to put a negative charge, and make sure to add this charge to the original one. For example, in this case, first one, HA, after removing one H, it will become A minus, because I'm removing a hydrogen and I'm adding a minus charge. In the second example, if I remove one hydrogen, it will become Cl, and I have to put a negative charge here. In the third example, I have NH4 plus, and I have to remove one hydrogen, so it becomes NH3 plus 1 minus 1, and the total is 0. And this is the structure for NH3. In the third example, if I removed H, it will become SO4. We have minus 1, and we have to add another minus 1, so this is minus 2, and that's why it becomes minus 2. To convert a base into a conjugate acid, you have to add a hydrogen, and you have to add plus 1 charge. For example, if we have B, we will just add H to it and a plus charge. NH3, add a hydrogen next to it, and this will be NH4, and then we add plus 1 here, because the original charge is plus 1 plus 0, so this is a total of plus 1. HO minus, add one more hydrogen to become H2O, and the charge is neutral because we have minus 1 plus 1, so that's 0. For CO3 2 minus, it will be HCO3. We have minus 2 plus 1, so that's minus 1. That's why we'll just keep minus 1 here. So this is how we convert acids into conjugate bases, or bases into conjugate acids. And this is an example. So let's say you are asked to complete this reaction. This is the acid, this is the base. Now someone might ask, how do you know if this is a base? Usually if you have something with a negative charge, usually, not always, this is going to be the base, and the other one is going to be the acid. So to convert the acid into a conjugate base, I will remove a hydrogen, and always make sure to remove the hydrogen which is next to the electronegative element, which is oxygen, not this one, and it will be transformed into CH3O minus, because I removed the hydrogen and I added minus 1 charge. For CH3O minus, I'm going to add a hydrogen, and I will add it next to the OH, so never write CH4O, okay, because as you will see later on when I draw the arrows, you will see that actually oxygen is the element which is going to pick up this hydrogen, and that's how we transform this base into this conjugate acid, and this is the complete equation of the reaction. This is another example where, again, if you have something which was a positive charge, this is definitely the acid, and this is a base. Again, I have, in this case, to remove one hydrogen from the acid and add a minus 1 charge, so plus 1 minus 1 is equal to 0, and that's why this is a structure of the conjugate base. With respect to the base, I have to add a hydrogen, that's why I have a CH2 here, and I have to add plus 1 to this negative charge, so the total will be 0, and this is the structure of the conjugate acid, and this is the complete equation of the reaction. Of course, you can practice. So this is the acid. I'm going to remove one hydrogen, it becomes NO3, and I have to put minus charge plus CH3OH. In this case, HCl is well known to be an acid, so definitely this is going to be the base. The base will accept a proton, and again add it to the element with the electronegative element, so OH2, and I will put plus 1 charge here, because remember we are adding a hydrogen and plus 1. For the second one, I'm going to remove the hydrogen and I put a negative charge. This is the base, it is a negatively charged anion. This is the acid. Remove a hydrogen from the acid, and make sure when you remove this hydrogen to remove the bond also, so put a minus charge. You can put a lone pair or not, it's up to you, plus NH3. It becomes a neutral because minus 1 plus 1 is equal to 0. In this example here, again, we have something which has a positive charge. This is definitely the acid. This is a base. I'm going to remove this hydrogen and make sure to also remove the bond. So the charge will be 0 because plus 1 minus 1 is equal to 0 plus H2O, which is again neutral. Finally, we have NH, which is acting as this is acting as a base. This is H2SO4 sulfuric acid, so this is a well-known strong acid. We are going to add one hydrogen to the base, and if someone is wondering why I'm adding this hydrogen to the nitrogen, this is usually the element with the lone pair is the one which accepts this proton. NH2 plus O minus, double bond O, OH. So this is how we complete acid-base reaction. The only thing which is left, how do we draw the mechanism of an acid-base reaction, or how do we draw the arrows? First of all, you have to identify the base, which is basically the protonated element in this space. And then you have to draw an arrow starting from the lone pair of the protonated element toward the hydrogen. So how do we do that? First of all, in this reaction, as you can see here, this is a base and this is the acid, based on what we learned before. After identifying the acid and the base, you should draw an arrow starting. If the lone pairs at nitrogen are drawn, you should start your arrows from those lone pairs. If they have a negative charge, you can start from the negative charge. Okay, so both are fine. The arrow should always start. Your arrow should always start from the base to the acid, not the other way around. This is one of the most common mistakes that students do, is that they start arrows from acids to bases. No, the arrow should start from the base to the acid. So the base is going to use its lone pair to pick up a hydrogen from the acid. Now we have to draw one more arrow, which is similar to the resonance. This is definitely not resonance, but similar to the arrows which you use in resonance. And you have to push an arrow from the bond toward carbon. So as if you are using one of the rules of resonance rules. So to make a long story short, you should always start from the lone pair of the first element or the base toward the hydrogen of the acid, and then you draw another arrow starting from this point and pointing toward carbon. Let's take an example. Again, in this example here, this is the acid, this is a base. Remember, look for the element which has a lone pair. This is your basic site. Starting from the lone pairs of this element, I'm going to direct my arrow to go from the lone pair toward the hydrogen of the acid. This is step 1. Step 2, you have to draw the second arrow starting from this point and going to bromine. And this is the acid-base reaction mechanism. Let's try to complete the mechanism for this reaction here. This is the acid, this is a base. Starting from the lone pairs of nitrogen or from the negative charge, I'm going to draw an arrow that hits or picks up this hydrogen, and then I will draw another arrow which goes from here to here, and this is how I get these two compounds.